Okay, so we're going to start polynomials now. Polynomial is the sum or difference of many monomials. The degree is the highest exponent. Basically what you need to make sure is the highest exponent is the term with the highest exponent is your first term. So this is called standard form because it goes from your highest exponent to your lowest exponent, which is the one that has no variable that's called a constant. All of these are coefficients. They're the numbers before your variables. If it has no variable next to it, it's called a constant, and n, of course, is positive. So when you talk about a polynomial, you're not going to have fractional exponents. Lead coefficient is the number in front of the term. In this case, my lead coefficient would be that a sub n. Okay, and those are important things because lead coefficient does tell you a lot. So one of the things you need to make sure of is that when you're looking at a polynomial, it is in standard form. This one is not in standard form because it does not go from highest degree to lowest degree. Right now, my highest degree is k to the fifth, so it's going to be negative k to the fifth, then negative 3k cubed, then 1/4, so positive 1/4 k squared, plus 8k, and then minus 1. Always ends in your constant. This one here, my highest degree, is the 4x cubed, so it's going to be 4x cubed plus x squared plus 7x plus 18. So little things that you need to know. If your degree is 0, it's called a constant. It's important if you're ever given this terminology. If it's to the first degree, that's called a linear. If it's a second degree, which means the highest degree is an x squared, it's a quadratic. Third degree is called a cubic. Fourth degree is called a quartic, and fifth degree is called a quintic. Also, if you're classifying by the number of terms, a monomial is just one term. 2 terms is a binomial. 3 terms is a trinomial. And basically anything more than 4 terms is going to be a polynomial. So you need to be able to identify this right here because my lowest exponent, when there's no exponent there, you write a 1. That's going to be a first degree. Okay, so that means it's linear. You don't have to write this. I'm just writing it. The lead coefficient is -3 because it's going to be the coefficient of the highest degree term. And the number of terms is 2, so it is a binomial. This is a fifth degree or quintic. You're not going to use that very much. Lead coefficient is 9. This has 3 terms. Again, this is important, just knowing what I'm talking about or what anyone's talking about when we talk about a trinomial. This one here has a 0 degree. It's a constant. It does not have a lead coefficient. The number of terms is 1, so that's what I call a monomial. Okay. Next one, this is a third degree. So this is a third degree. So that's a cubic, which it was just something we will refer to. Lead coefficient is 1/2. The number of terms is 4. So that's just going to be a polynomial. This next one, my degree is 2, so that's a quadratic. My lead coefficient, there is a number here, we just don't write it always. That's a 1, so that's going to be -1. And this is 3, so this is a trinomial. And the last one is fourth degree, which means it's a quartic. My lead coefficient is -3/2. It has 1 term, so it is a monomial. So now we go through just parent functions and end behavior of parent functions. So if you have a constant function like this, the equation would be y equals c. Okay, so my end behavior, well, on the right-hand side, so that's what we're talking about here, well, as x goes to infinity, actually y stays the same. It stays at that constant, and actually on the left-hand side, it's the same thing. and so that's going to be constant, constant. For my linear function, so a linear function looks like this. We have y equals x is the parent linear function. As x goes to positive infinity, well, y is going up, so y is going to positive infinity. So we have part of it's going up and part of it's going down. Okay, and so that's going to be positive infinity and negative infinity. Quadratic, parent function, of course, looks like this. Y equals x squared. As x goes to positive infinity, y goes to positive infinity. So that's on the right-hand side. On the left-hand side, as x goes to negative infinity, over here, y is going up, and so that's going to be positive infinity. A cubic looks like this. Actually goes through the origin. This is going to be y equals x cubed. As x goes to positive infinity, so that's this side, y is going to positive infinity. On the left-hand side, as x goes to negative infinity, y is going to negative infinity. And so you have a down on the left, up on the right. And so that's what we talk about in end behavior, what is happening to y values. A quartic looks like this. It kind of looks like a quadratic. It's just a little bit flatter here and then goes up even more. Would be y equals x to the fourth, or f of x is equal to x to the fourth. You see the left-hand side goes up, the right-hand side goes up. And so that actually tells me, remember that this is the right side, this is the left side. Well, on the right side it goes up, and on the left side it also goes up. Quintic is also very similar to a cubic. It kind of looks like this. It just kind of flattens out here. I have exaggerated it. This is going to be y equals x to the fifth. So on the left-hand side, it's going down. On the right-hand side, it's going up. So as x goes to positive infinity, which is on the right-hand side, my graph is going up. So it's going to positive infinity. On the left-hand side, which is where it's negative infinity, my graph is going down. We're looking at the y value, so that's going to go to negative infinity. So all we're going to do next is just look at a little bit of a pattern with these. So using your graphing calculator or Desmos, for these, for the bottom two, I'm just going to sketch it, but in class I'll be going to Desmos. So the first one, it asks you what the degree is. Well, I can tell from the equation it's a second degree. The lead coefficient is 1. And my end behavior, well, as x goes to infinity, y goes to infinity. What we have is it's going up, up. So it's going to be positive infinity, positive infinity. Okay? In this case, I have another second degree. My lead coefficient is negative 1 in this case. So very similar, except my graph is going on the left, it's going down. On the right, it's going down. So on the left, it's going down, on the right, it's going down. So just look at those arrows. You can ignore everything in between. Look at what's happening. Down, down means, okay, on the left-hand side, it's going to negative infinity, and on the right-hand side, it's going to negative infinity. Next one, my degree is 3. Okay, so what you notice is in my even degrees, I have up, up, I have down, down. My odd degree, my degree is 3. My lead coefficient is 1 in this case. I have a down, then an up. So this is, of course, this is my left-hand side, this is my right-hand side, and my left-hand side is going down, and my right-hand side is going up. And of course, negative infinity means down, and left. Positive infinity means up and right, just depending on whether you're talking about the x-axis or y-axis. This one here is a 5th degree. My lead coefficient is -1. And in this case, I have an up, then a down. So on the left-hand side, if it's going up, it's going to positive infinity. On the right-hand side, it's going down, so it's going to negative infinity. So what you notice is that this is to the third, this is a 5th, that if it's odd, it's going to be either down, up, or up, down. If it's even, it actually goes in the same direction. If you look at the next one, if we actually graph this, and this is what you do, you'd go through and graph it in Desmos, and this is what we look at. But my degree is 2 in this case, it's even. And right here, my lead coefficient is -2. My end behavior, well, that's a down, down. And that happens every single time, and we'll talk about that. So this is, sorry, down and down. Okay, next one, my degree is 3, my lead coefficient is half, so it's odd and it's positive, and so I'm going to have the left-hand side is going down, the right-hand side is going up. If you graph it, it looks something like this, and I may be asking for that. As x goes to positive infinity, so this is the right-hand side, it's going up. On the left-hand side, it's going down. Just be conscientious of that. All right, so in a nutshell, if you have something that has a positive lead coefficient, it's even, it's going to be up, up. If it's odd, if you have a positive coefficient and if it's a positive, if it has a positive lead coefficient and it's even, it's going to go up, up. If the lead coefficient is negative and it's even, it's going to be down, down. So up, up, down, down. Some examples would be you have your quadratic. So it could look like this, or you could have something really funky like this, or like that. Odd degree, it starts going down, then goes up. So you have negative, then positive. So it's odd and positive. So very similarly, you have your quadratic parent function. If it's odd degree, so 3, 5, 7, 9, all of those, it's actually going to reverse it. It flips it in the negative, and the coefficient is negative. It's going to be up, down. So it looks more like something like this. Okay. You could also have something where it kind of goes like that, or you could have something that goes like that. Okay, it can look funky, but you know that they're odd degrees. So just by looking at this, like this one right here, I know if it's down, down, I know two things. This has to be even, or this has to be even, and my lead coefficient has to be, sorry, I wrote positive, I meant has to be negative, because if it's going down, down, it's got to be negative. And I think for that one, it's easy to remember. For this one, we have a down, then an up, so I know definitely it's going to be odd. This is the only one that you have to remember, is that is lead coefficient positive or negative. In this case, my lead coefficient has to be positive.